Ave Coders, and welcome to the Python plotting crash course. Here we'll be looking into the data representation and mechanics of some libraries such as matplotlib.pyplot and Seaborn. This is not the course on data cleaning and data analysis. We're going to be purely looking at the mechanics. Furthermore, I'll show you what happens when you try to plot the data that you haven't cleaned prior to that attempt. This course was inspired by the work of Michael Galarnik, so credits to him. Alright, we'll begin with the matplotlib inline. This function allows us to plot stuff in the same window where we type code. Next, we import pandas and numpy libraries, as well as matplotlib.pyplot and Seaborn. In the next cell, we have Ave file variable, which holds the path to the file we want to import. You can access this file in the Ave Coders repository, but I took it from here, machine learning repository, where I went to the data folder, and here it was accessible as well. So I'll leave the link in the description so you can have this file and follow along. And here's another repository where you can look for the datasets. I will leave the links in the description for both. But this one, machine learning repository, is more popular among students. So here is the file bank.csv. This is how it looks like. So we don't have any understanding of the task, what we're trying to achieve with this file. All we do, we just explore. So basically what we want to do, we want to take this matplotlib.pyplot and see what options do we have, how we can represent these kind of files, and so on and so forth. So in here, I'm specifying that I want to read the CSV file. This is the path to the file, the separator, and some quotes surrounding the values in this file. That way, the library will know that the quotes are actually not a part of the value. So what we want to do when we have a file which we're not familiar with, we want to display first 5 records and see what's inside. It looks like it holds some customers' information, so we can see we have job, marital status, education, and so forth, and we can display some information. As you can see here, all columns are listed here. This is the number of values. We don't have any, not a number, which is values, which is great. And then we can start some exploratory plotting. So we're going to take some random values from some random columns, say age. So we basically are interested in the values of the age column. If you don't know how to use pandas, I'll recommend a lesson on my channel devoted to pandas. And we do the same thing with a job. So once again, I don't know how the result will look like. This is just the way we can plot the values of age and job. And let's add another set of values for balance. So df.log balance, then values. So we'll have something to probably compare them to. And now if I'll type in age and press enter, it will give me the array that contains all values from the age column. We can display the type of these values, despite we already can see that it is an array. And now we are basically ready to do our primitive plot. Now, because we imported matplotlib.pyplot with an alias plt, we can call plt.plot and put age and balance, better job and balance, because probably these two are correlated. The better job you have, then probably the bigger your balance is. And as simple as that, we can plot our first plot, which doesn't look nice, is messy. There are a lot of spikes. The info and the legend is not present, so we will correct that later on. But just for the illustration's sake, we can plot two graphs on the same plot. All we need to do is just put in the same cell that we want to plot job balance and age balance. And as you can see, it got worse. Now we have an orange hedgehog and some blue guitar, which tells us nothing, but it just illustrates how it is easy to plot psychedelic stuff with matplotlib. Alright, let's try to give it some style. So we call style and available, and here is the list of all styles we have at our disposal. Nothing really can save our plot because it doesn't make any sense, but at least we can add some classic style, so we'll fail in class. And in order to add style to our plot, we use plt.style.use, and then we pass classic. And I'll just copy and paste our job balance and age balance plots, and we can see it now has got some gray frame. The guitar is still blue, but the hedgehog this time is green. So there are a lot of green trends going on at the moment, so we are in trend. But what if we'll try some other style just for the illustration? I'm going to copy and paste the whole lot, and this time we're going to choose 538. There is probably a good story behind the name, but let's have a look how it changed it. So we're back to blue and orange. Let's try some other style. I'll scroll across and ggplot. Sounds promising, so I'm going to copy and paste everything and I'll change the style. And now we see that some values in the left bottom corner look like as if they were censored. But I promise to try the last style and won't torture you anymore. This time we'll try something called the Seaborn colorblind. I'm not colorblind myself, so please notify me in the comments if you spot some difference. But in theory, these colors should be great for the colorblind people, apparently. Alright, let's move on. So what if you want to change the color of these graphs? That is not a problem. We can always pass an argument that is responsible for the color and tweak it. So in our example, after the job and balance, I can put another comma and specify C equals, let's say, K. K, by the way, stands for black. And we can also pass the shape of the marker. So marker equals, and let's say we want it to be a dot. Then another comma and marker size. And we can put the size of 10. And I'll do the same for the second graph, but this time I'll use B for blue. And I'm pretty sure that conceptually it won't gonna change much, but as you can see, we have some dots at the top of the spikes of the graph. So essentially this is how you can change the color, the marker and the marker size. But let's go extreme. So this time I'll change the marker size to 50 and I'll change the marker for the second graph to X. Another trick we can do if we want to deviate from the standard colors, we can always specify the color in the RGB format. In theory, this is how we can achieve tones, but in practice, we don't really need that. Most likely your plot will be assessed by how much sense it makes, not in this case of course, but in theory. And our plot doesn't make a lot of sense, so the one on the left looks like a poodle. But I think the time has come to abandon this clinic and head to the GitHub repository Ave Coders, where we can download the next dataset. So here, third one from the bottom, table I702 CSV. So here is how it looks like. We have month, start and balance, and so on. This is the raw representation, and this is what we actually need. So this time we can actually specify the path to the file in the repository instead of downloading it to our local drive. So once again, I'll use the read CSV method to get this file into our notebook. Ave file. Let's put shift enter. That will execute the cell, and here we'll display the first 5 rows of the new dataset. As you can see, this is more about the ownership of the car, the lease, the interest paid, and so on and so forth. So df.info, and we can see all columns and number of values in each column. So this file, this dataset, is a bit smaller than the previous one, which is kind of good, so we can practice our plotting. So month number, this will be our first variable that will hold the values from the month column, and we'll also have values from the interest paid column. And I think another set of values that we'll need, I'll use the principal paid column. And that makes sense because the longer you pay, so the more month pass, the more interest you paid off, the less principal or more principal you paid. All depends on the deal. But it will be kind of logical to see one type of values will increase while the other will, on the contrary, will decrease over time. And now let's do the similar check. We just print the month number. So this is an array, as you can see, pretty straightforward, from 1 to 60. And once again, just to reiterate on that check, we put type and month number, and we should see the array as a type. Very good. So what can we do now? There are a lot of things we can do, but I don't want to bore you, so you won't be watching me typing all that stuff in. So I've prepared some code snippets that will have various influence on the plot. So here it is, and we can start from the top. So first of all, we're going to have 2 sort of types or styles. We have Matlab-style and or p-style, because matplotlib is designed to closely resemble that same library in MATLAB. That's why the names are so close. So let's execute the first cell where we plot the month number with interest paid and month number with principal paid. Again, we have black and blue graphs. And that shouldn't take long. As you can see, the month number increases while the principal paid decreases. We can also impose a specific limit to our axes, so the X and the Y. As you can see, it's 70 and 1000. So this is what it used to look like, and now this is what it looks like. So I think that we need some labels. So we can use the X label and Y label to set the labels. So we have dollars and month. And I didn't use the axis limiters for this example. Now it would be great to know what this graph represents. So we can use the title. plt.title gives us interest and principal paid each month. Let's now have a look if we can change the font. So as you can see here, for the X and Y label and the title, we change the font size. In all cases, the font will be slightly bigger. It's going to be equal to 15. And we can also change the size of the numbers on the ticks. So those numbers to the left and at the bottom of the graph, as you can see now, pretty big. They're very representative. So next is an OP style. The difference is that unlike in MATLAB, here we declare 2 objects, fig and axis, and we can use these 2 objects to utilize some methods. So basically we're doing pretty much the same as we did with MATLAB, but the methods are not called directly on plt, but they're called on the axis or the fig. So the first example is where we plot a simple graph, and we declare the colors as black and blue. The next one is setting the xlim and ylim. So once again, this is the hard border for our plot. Then the labels, once again for month and dollars, but this time, as you can see, we use the axis object to call these methods. We can set the title on axis as well, so interest and principal paid each month. And this is how we can change the size for the labels on the axis and the title, as well as the size of the ticks. So this time we call the tick params method, and the first argument will be the axis and then the size of the label. Of course, in practice, such a huge label size is not something we normally do in real world because it's going to be massive. But we can have a look as, you know, for the illustration, how it's going to impact our plot. And as you can see, it is truly massive. All right, let's move on. Now let's focus on the grid itself. So we can change the various grid parameters. Let's remind ourselves of this simple graph and work from there. First of all, if we're going to use the method .grid without any parameters, we're going to get no grid at all. Now, if I'll just pass, say, one of the parameters to this grid method, say axis equals y, we will only have the y vertical lines, and similarly just the x, just the horizontal lines. But we can also pass some other parameters to the grid, so the color, the thickness of the lines, and their style. So this is how it all will look like. And down below we can observe the similar methods, but in the OP style, where again we use the fig and axis objects. So this is no grid at all, and this is with only y's, and down below only x's. So only horizontal and vertical grid. Similarly here we pass these arguments to the axis.grid, and as you can see, I'll run this one first. The thickness, the color, and the style of the grid lines very much in front of you. And the last one, we use the style of Seaborn. We specify the colors of the lines, and as you can see, it looks pretty familiar. And yes, this is a very popular style. Let's move on. Next, we're going to talk about the legend. A legend is basically a box which specifies what's what on our graph, and we can do that in MATLAB and OP styles as well. So let's see the first example. We don't specify the location of that legend explicitly, we just call that method, and this is what comes up. So once again, all settings will be defaults. As you can see, it looks ugly. It overlaps with the blue line, and we can find a better place for it to be. Let's say the center right location. It might look good in this particular situation, but it's not really good practice to place it there. We can also specify the location with numbers like coordinates, and let's see if it makes any difference. Yes, it has moved the legend to the outside of the graph, and nevertheless it managed to stay away from any interceptions. It's not really good practice to place it there either, so the legend should be on the graph. Alright, and this is pretty much the same concept, but using the OP style with axis and fig objects. So here the legend overlaps with the line, So the next one is the center right, and the last one is where we apply numerical values to the location of the legend and places it outside of the plot. Alright, let's move on and we'll use the classic style next. And this is the style you might encounter in plots in the articles on Medium or towards data science or in some tutorials, and have a look if this is something that really looks familiar. So here the legend placed in the top right corner. The background of the legend is opaque and therefore the line does not go through. And here are some more examples I've prepared. You can stop the video and study them carefully, or you might go to the Ave Coders GitHub repository and fork them from there. Here we pretty much use all the goodness we have studied so far, and as you can see, we even can save the plot to the hard drive. And this is something we can do just by using the method savefig. And this is some other example which uses the tight layout method, and it saves the plot as well. And the code down below will produce pretty much the same result, but this time using the OP style. Let's have another look. That looks pretty well. And once again, it will be saved to my local drive, and the same goes with the next example. Alright, so let's try to use another data set, and this time we'll explore a plot called the box plot, and we'll do it for the matplotlib and for Seaborn as well. So in here I've just reverted back to the state we were at the beginning of the tutorial, and this time I'm going to import, here is the, by the way, here's the GitHub repository. Here's a raw file, and it is a wisconsinBreastCanser, very famous data set. So I'm going to use it in this example, and next we can peek at the first 5 rows of the dataset, df.head. And once again, this dataset is very well curated. It was around for many years. So first we're going to check the values in the diagnosis column, and there will be 2 types of diagnosis we are interested in. Those would be benign and malignant. So we're going to count how many benign diagnosis and how many malignant diagnoses we have, and we'll set up drop-in to false. So as you can see, we have 357 of the benign and 212 of the malignant. So first we're going to deal with the malignant cases. So we're going to declare a variable malignant, and by using the log function we're going to filter through the values in the diagnosis column, and we're going to pick only those that have letter M, which stands for malignant. So we're going to plot the malignant diagnosis on one axis, and the other axis will be the area mean. And again, we want their values, so we use values. And the same will go for benign. Once again, we will filter through the diagnosis, and this time we are interested in the diagnosis with the letter B. And once again, the other axis will hold the values from the area mean. All right, and we're going to use a type of plot called the box plot. And in order to do that, I'm going to use plt.boxplot. And I'm going to pass these variables as the arguments to the box plot. So malignant and benign. And it will be pretty logical move if I'll use the M and B letters as labels for the axis. Let's try and plot it. And here I've got a little typo somewhere. So df.lock, not df.love. Right, so let's try again. So box plots are visually good to show the distribution of numerical data and skewness through displaying the data quartiles or percentiles and averages. And here we have our beautiful box plot. Another advantage of box plot, we can plot it with minimum coding and minimum values. So let's say we have column area mean and then by diagnosis, and this is enough to plot a meaningful box plot as well. So we don't necessarily need to filter and build that complex construction we did previously. So this is another tip, and it shows why this library is so popular. Another thing, we can change the title. As you can see right now, it displays area mean. So this is the label for the column, and it was used for as a title for the box plot, but we can also change that. So the first line of code displays what we want to plot, and then we can call the title and subtitle. And I have a little typo here, so has no attribute subtitle. Right, weirdly enough, subtitle is written with the letter P. But anyway, I've dropped the title and I've just used the subtitle diagnosis. Another thing is that the box plot is present in matplotlib and it is present in Seaborn. So if I'll start typing something like SNS, which is an alias for the Seaborn, this is how we have imported it. And I'll use the box plot, and X will be labeled diagnosis and Y will be labeled as area mean. And this is the data we want to pass to this box plot. So in this case, this is our data frame. And despite it has got a little bit different style, everything else is the same. Now, another important plot, especially in data science and machine learning, is the scatter plot, because it allows you to see the distribution of data. So here we have two arrays, two lists, temp and the sale. And let's say we want to see the correlation of temperature and sales. Let's say we are selling the ice cream. Let's imagine these are degrees in Celsius. So the temp is degrees in Celsius, and we have the number of the ice cream sold. And now we just scatter plot the data, and we see that the biggest sales we did were about when the temperature outside was about from 25 to, let's say, 32. So this was a brief overview of the scatter plot. The next plot we're gonna look at is called the bar plot. So here we construct the data frame that contains the means for 5 exams taken by a set of students, and we're going to save it into a variable called exam mean. So here they are, the exams and the mean for the exam. And down below we can use plt.bar to plot the means and the exams. As you can see, this nicely visualize what the results were. All right, so the next plot is beloved by the salespeople. It's called the pie chart. If you're trying to work out the composition of something, for example, you have categorical data, then the pie chart is the way to go. So in this example, we will display which works, which types of works did contribute to the final mark for the module. Here we're using the fig size to declare the size of the figure, and then we call the pie method to display the overall results. So we have homeworks, labs, quizzes, midterm exams, and final exam, as well as their corresponding weight. So here's our beautiful pie chart. And we can clearly see that the final exam corresponds to 33% of the overall mark. So that is the pie chart, but let's move on and we'll talk about another important type of plots, histograms, where we have, for example, variables whose values are numerical and measured on an interval scale. It is generally good to use histograms when dealing with the large data, for example, greater than, 100 observations, because histogram can also help to detect any unusual observations, so-called outliers, and is also great for plotting the distribution of data. Now, subplots, they are not a separate category of plots. This is basically done so we can compare two plots. For example, we can display them side by side or display two different distributions. So here we have exam grades, and we're gonna use plt.subplot to display two subplots. Pay attention to how we utilize the axis object with different indices 0 and 1. And these are two histograms displayed side by side for the exam 1 and the exam 2, the distribution of grades. And there are a few more plots that you might encounter. One of them is kernel density plots. So kernel density plot is used to observe the distribution of a variable in a dataset. So it plots the graph on a continuous interval or time period. All right, so here we initialize the mean, initialize the covariance matrix, and then we initialize the data as a two-dimensional NumPy array containing random samples drawn from the specified bivariate normal distribution. And after that, we use the KDE plot to plot the scores. So first we'll create a standard kernel density estimate plot, and later on I'll show you how to do a shaded version of this plot. All we need to do, we just need to specify shade equals true. All right, and here's the trick. So down below we will display the midterms. So here they are. And here's the trick. If we'll supply two arguments to the KDE plot, we'll see that the plot has changed. And if we'll add the shade, we'll see that the density, now the closer the values are to the mean, the more dense, so the darker the color is. All right, let's move on. So the next plot we're going to have a look at is called the Violin Plot. And as you might guess, it got its name from this musical instrument. And here again, we'll create a NumPy array representing the scores of 4,000 students, then representing the students' scores on midterm 2, and then representing students' scores in the final exam, and so on. And finally, an array that contains all the scores. Then we create the data frame with midterm 1, midterm 2, and final exam scores for the class of 400 students. So here it is. And now we'll try to plot the Violin plot. Here we have a label score, and we supply the exam scores. And if you'll tilt your head, you'll see that this is nothing more than just the distribution, the famous bell-shaped distribution, but just attached to each other with a base. In my humble opinion, this is the most eccentric plots of all. So the next one is called the heat map, and it's used to show the relationships between two variables, one plotted on each axis. By observing how cell colors change across each axis, we can observe if there are any patterns in value for one or both variables. So here we have a variable that contains a NumPy array representing the sales of a small business for each of 12 months. Then we have a variable that contains the list of months. Then there is a variable that contains a list of years from 2008 to 2020. And there is also a variable named sales that contains a data frame that consists of the sales of the small business over this 12 months. And then we plot the heat map. So the legend on the right tells us that the brighter the color is, the better were the sales. And here we can see that, for example, February of 2008 was a brilliant month in terms of sales. All right, so this was the basic overview of the major plots that you can find in Python libraries such as matplotlib and Seaborn. That was V. Please give this video an thumbs up, toll the bell and subscribe, and I'll see you in the next lesson. Thank you and goodbye.